Okay, been playing around with this and thought about doing some conversion of loads of sorts and changing some frequencies. Um, what's going on is if I turn the controls when this bulb is a lot brighter now. Let's see. You can see that one is barely lit and that's dark. I'll cover this one up, and this one's very bright. Um, This one's still capturing back EMF, but there seems to be interference between the pickup coil, which is wrapped underneath the T coil. Um, Maybe it would be better out and I could try some different things because I was doing it caveman style when I had to keep the coils on the outside, so I might be missing something. I'm using less magnets right now. Um, Let me see what the voltage. She's drifted a bit. It was 9 point. Let me see. 9.4 volts on that bulb at 191 milliamps. Using the same caps to help steady the voltage for the measurement. Um, so whatever's going into the bulb, it's creeping in from the cap and the input. So it should be pretty good. It's a good meter. 1.79 watts, and on the big bulb we've dropped down from 3 volts. If I change the frequency, this one will get brighter and that one will get darker, but so far I just wanted to measure what we were getting here. 3.4 volts, 300 milliamps, so that means since the filament was cooler, there was more current flowing through. Seems like almost no matter, once you get above a certain voltage, the milliamps sort of stay the same as you climb. Just got to be able to support the voltage at that amp rating. My last thing was 3.32 watts, and now we're at 3.8 watts, and I measured the input. I do it all the time. We were at 870 milliamps. So we're getting closer from here to here. We've got a long way to go. But anyway, I can show some things. Let me see if I turn this control. See how that bulb gets brighter over there? So there's some kind of taking and giving here. What I was going to show also, Kitty, hold on. What do you want, some snacks? Do you want some snacks? You want some food? Are you hungry? Yeah. What do you want? You want orange snacks or green snacks? My tools. You want some orange snacks or green snacks? Come on. Yeah. You're a good baby. Alright. I didn't get to show this in my last video. I wanted to take this bulb out. And we'll stick it in here. And that's how bright it is. Turn off the light real quick. This is off of the 5 volt power supply. You can see when I remove that bulb, this one gets a little bit brighter. Let me put this back in. Take it out, that one gets brighter. And it's not because it is actually getting more current, getting brighter. Now we can also show this. And what I'm going to do is pull the transistor out, and that'll take the load off of the generator. So you can see there's not much difference there. So there's plenty of room on the power supply for lighting the bulb and running the circuit. Okay, let's put this back over here so we can show the difference in brightness. Big difference. We can take this big bulb. We take that one out, this one gets brighter. Actually, no, I think it's backwards. Hold on. I was going to make a statement about that. Let me see. Okay, that's the brightness that is, and now I'm going to pull it out. It was brighter when I had it in. Now you'll see a pulse because, let's see, take it out. Yes. So taking up the back EMF allows me to have more power on the output. So this is an advantage here. Even though it doesn't look like we're getting many watts, we're getting some watts out of this. And it's helping the output on this side, which is fine trade-off, I guess, if you could work the combination of things. Um, what else was, oh, I'm going to take this bulb out and put it on the output here. You can see it loads down the circuit. This is a much heavier bulb, and it lights up to that point. Let me see. Get it to stay. Take out the transistor. Not much difference. It doesn't really change much. So, but the output that we can get this in here. I wanted to show this real quick. I'm probably going to damage some caps. I was saying I was going to show some stuff in the other video, and when I looked it over, I didn't show nothing. Come on. I'll put another cap in here. Okay, I'll pop this bulb out and pop it back in. She's not doing it. Before it was actually blazing, but the circuit acts differently in different configurations of just frequency and things like that. I dropped my the timing cap popped out. But anyway, I just wanted to show that even though it looked like we lost something here and gained something here and there was a trade-off, the efficiency went up from the last time, because the last vid I was using definitely above 1 amp it was showing using, and going through these caps, the circuit absorbing from the caps and me measuring here, it should be a pretty smooth flow of current that we're measuring. And it seemed pretty solid and everything, it wasn't jumpy at all. But here we lowered our current input and we raised our power output, reduced our power input and raised our power output. So where are we at? We're about 55 point, about a half a watt difference. 0.55 watts is what I have to make up. And the strange thing was I was getting this output using less magnets. So you see this gap in here, there's that much of a gap on the other side also. So in this particular frequency and configuration, I do all these changes for every configuration. Go through this change, that change, and this one needed less magnets. It's running at higher frequency also. So if I put the magnets, if I stack these magnets till they're out about an inch here, the only thing we're going to get is back EMF, because this field coming all the way out here really has no chance of locking into this center toroid. It's going to come out and around and back to this field. A lot of it. So there's going to be some that comes down the sides, but not compared to the total amount of force that's coming out of the end of the magnets. So here, since we shortened the pole face at higher frequencies, it seems to be working better. I don't know the frequency. I can measure it, and if anybody wants to know. Anyway, that's about all, folks. Little changes makes a lot of difference.